Okay, so you should already have this test output, and yours will have different numbers, of course, because you had different countries in your sample, or maybe even did a different variable. We're going to calculate several things here. Stick with it. I'll explain. What we really want is the green and the blue here, but it's important to know how to get there, just in case you want to make changes along the way and get slightly different type of result. So differences means just means in terms of the average for the prosperous countries and the average for the less prosperous, how much difference was there? So this is just a subtraction. We put an equal sign, just click on the first one, minus the second. So there were, in my case, I was doing the ecological footprint, so there was a difference of 4.3 lobes there. And go back to that assignment for what that actually means. Standard error for difference. This one's a bit trickier. So what I want to do is each of these groups has a variance. But the problem is because there were different sizes of samples for the prosperous and the less prosperous, I want to take a weighted average. You may remember that from your week. So I'm going to type in average weighted, and I'm going to select the values first, then a comma, and then the sample sizes. This here would be my kind of a weighted variance, you could say. But what I really want is the standard deviation here. So I need to take the square root of this yet. So I'm clicking back on this, clicking in the formula and typing in SQRT, putting a parentheses before and after that weighted average. And this will give me what's called error. And don't worry if that term sounds pretty fancy right now. The margin of error is, yeah, actually, probably didn't have these in the best order because the t critical needs to be determined before we can get the margin of error. So let me go ahead and do the t critical. So you're just going to put t dot inv dot 2t, two tail, that is. The probability is whatever your alpha level is. So we're going to use a 0.05. Remember, we're trying to get a 95% confidence interval. So the other percent, 95% chance that we'll catch the difference, true difference in means, 5% chance that we won't. So that chance for error is what we would put in here. If we wanted a 90% confidence interval, we would have put 0.10 here. So this probability is the opposite of whatever our confidence interval is. I'm going to put a comma. Degrees of freedom, you'll see this DF right here for degrees of freedom. So you can click there. This number, if you look closely, you should be able to find it elsewhere too. This is given to you. The output assumes here a 95% confidence interval. The nice thing with this formula, knowing the formula, is you could actually just change this, and then it would change the rest of your results for a different confidence interval. So knowing that formula gives you a lot more power on which kind of confidence interval you level of confidence interval. Okay, now the margin of error is actually straightforward. Just an equals, all we have to do is multiply critical times standard error. That gives us our margin of error. And if you remember back to the polls and surveys from previous week that this is that plus or minus thing that goes after our best guess. Our best guess for Biden or Trump, certain percentage, plus or minus, that's the margin of error. So we just looked at how to calculate. And then similar to what we did in the confidence interval week, the lower limit of the confidence interval is just our average difference in means, so our difference in the two averages, minus this margin of error, and the confidence interval upper, put an equal sign. So again, the difference in means, but this time plus that margin error. So that's that plus or minus situation, and that gives me the confidence interval. I'm going to clean these up a little bit. I'm going to drag over these numbers, go to Format, Number, and maybe right here, just to make it a little easier to interpret. So how do I interpret this confidence interval? Well, we know just as before, it's saying that we're 95% sure that the population average is between those two numbers. But this one's tricky because there's two samples we're dealing with here, and two populations for that matter, the prosperous countries and the less prosperous countries. So what this confidence interval really is, it's 95% confidence that the difference between the two groups, the two types of countries, is somewhere between these two numbers. Let me say that again. Specifically, because the prosperous countries were using, had a heavier ecological footprint, we can be 95% sure that the prosperous country's footprint is somewhere between 2 and 6.6 Earths more than the less prosperous countries. So even in the best case, it's hard to say best case scenario for the prosperous country, still using 2 Earths more than the less prosperous countries, but it could be a much, much worse situation. That's what the confidence interval. When you're dealing with a two sample test, confidence interval is looking at the difference, how much more one group is than the other group. Let me just give you one more example because I know this is confusing. Let's say we were doing male and female heights, average heights. Our 95% confidence interval might be something like 3 to 7 inches. That's not the height of the male, it's not the height of the female, it's how much taller in general we think males are on average than females, somewhere between 3 and 7 inches. How much more one group is on average than the other group.